Okay, so what we're going to go through today is we're going to go through the Scuba Force SF2 rebreather. This is one fully assembled, kind of how it looks when it's fully assembled. Nice thing about the Scuba Force SF2 is it looks really cool in its carbon fibre. So this is the carbon fibre tube, which we're going to break down and we'll show you in a minute. So this is a completed one, just to give you an idea of what the unit looks like fully assembled. Some of the interesting features of the SF2, as we go through, I'll point those out, and we'll contrast those with the differences between the SF and the JJ that we looked at the other day. So you can kind of see the two differences between the machine. There are a lot of similarities, especially with the electronics being a shear water rebreather, but you'll see those as we go through each individual one. Okay, so I'll move this one out of the way. Okay, so this rebreather is stripped into parts, and like all of our build-ups, we're going to need our checklist. So I've got the SSI SF2 specific checklist, and the first thing is to put my name and details on the top. Today's date, and the serial number for this unit, and this unit is 750. Thanks for that. Okay, so first thing to do is before analyse, assemble, pressure check my bailout. So I'll just get my bailout, which is right here. So always make sure your bailout's ready to go with all rebreathers. That way you won't forget it. You're going to make sure that it's ready in any event of emergency. So we're going to analyse our bailout. Pressure's good, analysis is good, and the markings are all still correct. So that's my bailout assembled, ready to go. Got my off-board plug-in ready for my rebreather. I'll put that to one side. Okay, so bailout's ready to go. The next step is to analyse and pressure check and verify the contents of our onboard cylinders, one for diluent and one for oxygen. So you'll notice a small difference between the JJ cylinders and the SF2 cylinders. The SF2 cylinders, rather than having the inline valve, these have a left and a right hand modular valve. Okay, makes it a little bit easier to get to the valves when they're on the unit. And they also have got the cylinder clamps attached to the cylinder. So this means that they fit onto the cylinder using these clamps rather than a Kanban like the JJ. So these two cylinders really aren't interchangeable between the two rebreathers. This is a specific set that we use for the SF2. So we have one with diluent, and the same thing but the other handed valve for our oxygen. Okay. Same as before, we need to make sure we analyse those. Super. I can mark them up. That's my diluent, which is air. And the oxygen. So I'm pretty confident that I've got the right gas in the cylinders. can mark this one up as well. So once I've marked them on here, I'm just going to pressure check them and make sure that I write it onto my checklist so I've got that record for later on. So the 180 bar in the diluent. And in our oxygen we have 190 bar of oxygen. Okay. So that's both of my cylinders now analysed. So the oxygen's analysed, diluent's analysed, both cylinders are marked, both cylinders have been pressure checked, and now I can tick it off on my checklist. The next step is to fit the two cylinders to the unit. Now, this is the base of the SF2, okay? And the base of the SF2 depends on what you're going to build. This is the back-mounted base, okay? The SF2 can come in as a back-mounted machine or as a side-mounted machine. So, over here, I have a side-mount base and a back-mount base, so you can see them next to each other. The back mount base has a 11-inch adapter here to allow you to connect a backplate, a harness and a wing, whereas the side mount base is just the tube itself without that connector on it. Okay, so it makes it a little bit easier now side mounting. You don't need to worry that this is going to be in your way. So the side mount base, of course, we have also got it set up with the clips on to allow you to side mount it, and some other little bits of accessories on there for side mounting. I'll come to this later and I'll show you the variation between the machine as we go. This is the base for the back mount version, and this is the base for the side mount version, okay? Pretty much the same. I'll be building the machine without the wing, backplate and harness on. The reason to do that and not build it on is that you guys can see what's happening. At the very end I'll put the backplate, harness and wing on. But if you were building this for yourself, you probably wouldn't have taken the backplate, wing and harness off. So just in case it's for visibility for you guys. Okay, are these cylinders specific for the SF2? They work better like this. It doesn't mean that you can't use another cylinder. You can use an inline valve like on one of the other rebreathers. It just means that the valve handle will be a little bit twisted away, so it won't be so easy to reach. But absolutely, it's really possible. One of the things that's slightly different between the SF2 and the JJ is that the SF2, on the first stage, we actually have shutoffs where we can isolate the gas flow. To be able to reach those in the best possible position, you're better with left and right-handed valves, but again, not really a problem. You can go with the inline valves if you need to. But left and right-handed valves actually are more easily accessible than inline rebreather valves. Especially inline rebreather valves are only designed for rebreathers that only work for this. This is the same valve that you would use on a twin set, the same valve that you would use on a side mount set, so they've just got the blanking plugs in to be used. So probably a little bit easier to get these valves than actual rebreather valves if you're somewhere where rebreathers aren't really all that popular. So I'm going to install them to the machine. This 11-inch adapter obviously fits on my back, so this is how I would wear the machine in this orientation, meaning that rich right and lean left, again the same as our other rebreathers. So our oxygen fits on to the right hand side of the machine. You can see on top of the bracket for the cylinder, I've got a push button, okay, and that's just a little spring that pushes in and allows the cylinder to fix properly onto the base. So there's the base. All we need to do is align our clamp up with the base. We put it in there, comes to the top. You're going to need to press the button to let it clip into place. And so that's the oxygen side fitted. we're going to do exactly the same thing with the diluent side. So again, I'm going to clip this one on there, put it into place. Once I'm ready, just press my little button and that'll fire into place. So now I've got my 2 cylinders mounted on the rebreather. Again, a little bit like the JJ, what I can do is I can move the cylinders up and down to adjust my trim slightly and to adjust how easy they are to reach in terms of the position up and down the back. So that is our cylinders connected. Okay, we also, as part of this step, need to connect both first stages. So when you have your wing and your back plate in place, your first stages and regulators will already be in place. I'm going to show you the regulators now. So this is the regulator set that I'm using for the SF2. The SF2 comes in two different builds. You can buy it as a fully set up machine, or you can buy it as a stripped rebreather. Put those over here a little bit so you can see. The stripped rebreather is available without a backplate harness wing or regulators. So if you were already diving with a twin set and wanted to move to rebreather, it would make sense to buy the stripped machine, because you could use your harness, backplate, wing and regulators and just put those directly onto the stripped rebreather, and it kind of reduces the cost and means that the rebreather is a little bit more familiar than it would be if you had to have a new harness and everything as well. So that's the point. So these regulators that we have here, these came off my old twin set, and these are a pair of Apex Tech 3s, but it doesn't really matter what regulator you use, honestly, as long as they're set up properly. These have had the environmental seals removed so that they don't overbalance, and they've been fitted with a slightly different top than the normal Tech 3 to make that happen. They've also got overpressure valves, so the same as you see on any rebreather, especially the JJ, we've got these overpressure valves that mean if the gas supply is isolated, so turned off, and I ascend, the pressure in the hose has got nowhere to go because the flow's turned off. And so it means that that pressure can escape somewhere. It doesn't blow the hose up, or it doesn't create too much pressure inside the first stage, damaging it. So the overpressure will come out the overpressure valves. If you're using a regulator where there's no second stage, downstream second stage, you're always going to need an overpressure valve anyway, like a dry suit inflator or something like that. So these both have got overpressure valves in, they're both set. Now, you'll notice that they're actually connected, these two regulators. And this is slightly different to the other rebreathers. So, for instance, the JJ, the oxygen side is the oxygen side, and the diluent side is the diluent side. What we have, along the MAV valves, so the manual addition valves, just move that into a nicer place. Okay, so this is my diluent manual addition. Gas comes along this hose here from the first stage. Okay, so it comes from the first stage up this hose and through a gas isolator, so I can turn the flow of gas on or off, and into my manual addition valve. The manual addition valve, if I press the button, gas will flow through the valve and down this hose. Okay, and this is the point at which the two first stages are joined, because I've got a 2 to 1 splitter. That means the gas coming from the manual advap valve goes into the rebreather via one hose. The oxygen manual addition, where the gas comes in through this hose from the first stage, same thing through the MAV and down this hose into the splitter and into the rebreather at one point. Okay, so the gas injection on this rebreather is at one point. Okay, that point is at the base of the machine. Okay, before the scrubber. So the gas from your manual add-in, whether you add manually oxygen or manually diluent, they go in at the base, go through the scrubber before you inhale them, so it gives the gas time to mix. On the JJ, if you remember, our manual oxygen, we were manually adding oxygen into the exhale counter-lung, so over our shoulder, and it was going into the counter-lung and then mixing and coming through the rebreather. But diluent, when we manually added diluent, it came on the inhale side, so before the scrubber. Okay? So slight difference between the two rebreathers. Both gases are added at the same point on the SF2, and on the JJ they're added at slightly different points. If you take a look at the manual addition button itself, you can see that we've got our inline gas isolator to allow us to turn off the flow and then allow the gas to flow again. We've got here a nipple where we can fit off-board gas. This is not a low pressure inflated fitting, it's a slightly bigger fitting with more flow, and that allows us to plug in off-board gas. The off-board gas on this rebreather can, of course, you plug it in, you press the button, it goes down and enters the base of the rebreather. But the nice thing about this rebreather is if you add gas and you have this isolator in the open position, the gas will flow back into the system through the regulator and to all the other systems. Okay. What does that mean? On the JJ, for instance, if I plug in oxygen to the manual addition valve because I've run out of oxygen on board, I can then add oxygen manually directly to the counter lung, and that's it. With the SF2, if I run out of oxygen on board, I can close the cylinder valve if I like, plug in the oxygen off board, and provided all the hoses are intact, oxygen will flow back into the first stage and flow back out to everything else. So it means that my solenoid will start to work again. So in the failure mode that you run out of oxygen on board, I can just plug in oxygen off board and my machine will work like it did before. With the JJ, if I run out of oxygen on board, then I need to go on to fully manual running. So I'll be responsible for the amount of oxygen on board, and my solenoid, I can't get that to work again. So it's a nice step. Okay. Same thing happens on our diluent side. If you lose diluent, and this actually happened to me in Egypt last month, one of my overpressure valves failed and it emptied the diluent at 100 meters. And so my diluent just disappeared. I could hear the bubbling, couldn't stop it, isolated the oxygen, and all the gas had gone from the cylinder. So what I had to do was plug in off board oxygen, and I could manually then run. When I switched the isolator on, it allowed gas to flow back to the first stage, and the isolator, the overpressure valve would shut itself again now, and it meant I could access my ADV, I could access my wing, and everything worked like normal. So those wouldn't normally work on another rebreather. So a nice function of this rebreather is plug it in, and opening the supply to allow the gas to go back means that we can then access all of the other devices that are connected to that first stage. Okay, so breaking it down. This is my diluent first stage. The diluent first stage has an overpressure valve. It has a flow up to the two-way connector. One goes to my BC or wing. One goes to a manual addition valve. I have a manometer or an SPG that allows me to check the amount of gas that's inside the rebreather, inside the cylinder. And then I have this one. And this flow here is connected to a quick connector, and it has an isolator in line. Okay? So this flow is for my ADV, so my automatic diluent valve. Much like the JJ, to shut off the ADV, I would reach up onto my shoulder and shut off the ADV on the JJ. On the SF2, I'm going to reach behind me and isolate the ADV right at the first stage. Okay, so I'm not isolating it at the end of the hose like I do on the JJ. I'm isolating it at the beginning of the hose on the SF2. Okay, it's also got a quick fitting. So rather than a screw connector, this is a push and then lock quick disconnect. Means that it's a little bit easier and a little bit quicker to fit. That's my diluent side. On my oxygen side, very similar. I have a feed that goes directly to the manual addition valve. I have an SPG or manometer to allow me to monitor the amount of gas in the cylinder. And then I have this feed here, and this is a longer feed with, again, an isolator on it and a quick disconnect. And this is the feed for my solenoid. So this feeds the electronic head and allows oxygen to be added by the solenoid due to metabolism. So as we metabolize gas out of the loop, the solenoid will put it back in and it comes via this hose. Again, on the JJ, there's no way to isolate the solenoid without turning off the cylinder. So if I was on the JJ now, I would turn off the cylinder and that would isolate my gas flow. I would lose manual addition on board and I would lose solenoid. On the Scuba Force SF2, if the solenoid on board sticks open and I want to isolate it, I can reach back and isolate the solenoid alone. So the solenoid feed will stop working. The solenoid will still be opening and closing, trying to put gas in, or it'll be stuck open, but there'll be no gas flow to the solenoid. Because I've isolated the flow to the solenoid, it means that I have not isolated the flow to the manual add. so the manual addition will still continue to work. All right? So again, slight difference between the two machines. What I'm going to do now is I'm just going to pop these regulators on so that we don't break our checklist. Turn the machine to face you a little bit. Fit my oxygen first stage. That's the oxygen first stage fitted, and now I'll fit the diluent first stage. Okay, oxygen first stage fitted, diluent first stage fitted, and I'll lay the hoses out a little bit so you can see them. So hopefully you guys can see that. What I've got there is I've got my manual addition valves for oxygen and for diluent, and they come from either first stage, one from the oxygen side, one from the diluent side, and then they go back to our single point of entry for the rebreather, so they enter in the same place. Each side has a manometer or an SPG. The diluent side has a BC fitting. And then each one, I'm left with a quick disconnect on each side. On the diluent side, it's going to fit my ADV. On the oxygen side, it's going to fit my solenoid. Okay, so Sam asks, sounds like the SF2 has got a lot of bases covered if things go wrong. Yeah, absolutely. So all rebreathers, and included with the training, mean that you can cover most eventualities. With the SF2, it's designed in a way that a lot of the functionality remains even in a failure scenario. Whereas the JJ is designed in a much simpler format, so the idea of the JJ is nothing that's not required at all, and the only thing that happens is if you get a failure mode, is then you move to a completely different skill set. So it depends on your thinking really as to what you believe is the better option. There are just differences between the two machines. Both machines are capable of doing exactly the same job. However, if you have a, let's say, a stuck open solenoid on a JJ, you'll need to isolate your oxygen and then either plug in off-board oxygen or bail out. With the SF2, you've got three options. You can do exactly the same thing, isolate the O2 at the valve, plug in off-board, manually run. You can bail out, or you can isolate at the first stage, okay, and continue to manually run using the onboard gas. So you have to couple the training with the design of the machine. And once you have both and both are good, really the design is more about your philosophy than the machine's ability to deal with the problem. Certainly both machines have been shown in the field to be really capable of dealing with problems in both ways. Yeah, I'm sorry it's all a bit mirrored, but if I don't mirror it, I can't see myself, so I don't know if I'm in the middle of the screen or not. Hopefully we're going to figure out a way to do this where we can flip the video live somehow. But I hope that's answered your question, Sam. If you guys have got any more, by all means, just ask us. So that's our base part complete. Of course, your wing and backplate stuff would be on here. Just keep that in mind. So I can tick off on my checklist: oxygen, diluent cylinders on the unit, and both first stages connected. The next step is to verify the counter lung is free from any debris and inspect for damage. So this is my lower section of the SF2, and this is our counter lung. Okay, so what you can see if I let go here is the counter lung is like an accordion. So we have a single counter lung on the SF2 that's an accordion at the base of the rebreather, and it sits in this orientation here. And as you exhale, it's going to expand, and as you inhale, it's going to come back. So if we compare that to the JJ, with the JJ we had two count alongs, didn't we? An inhale and an exhale count along on sitting behind our back. This is going to sit at the base of the rebreather here, so at the lower part of your back, and extend and contract as you breathe in and out. What does that mean for the diver? Well, having the count along at the base of the rebreather, okay, means that as you inhale and exhale, you get a slight shift in buoyancy. So you get a slight shift in trim. With the single count along design, okay, the single count along design means that you've got less chance for the gas to cool. The chemical reaction inside the scrubber is best when the temperature is warmer, okay, and our life will last longer. This means that by having a single count along, there's only one point at which the gas is exposed to the water. On the JJ, when you exhale to the right hand side, it sits for a moment in the exhale count along. There's some gas exchange, some temperature exchange here between the water and the gas. It then passes through the scrubber. As it goes through the scrubber's an exothermic reaction, so it produces heat. That comes into the inhale count along, where again there's a heat sink happening, and then you inhale. All right. So with the single count along, it means that when we exhale, the gas is only against the water column once, and then it's inhaled back through the scrubber. So there's less gas in contact with the water, so it's not in contact with the water twice, and that means the gas stays a little bit warmer. Okay, so let's take a look at the rest of the inner section. So the count along itself, I'm going to inspect it for damage. I'm going to look inside all of the convolutions and make sure that it's all in good condition. The nice thing about this is it's really well protected. It sits inside this carbon fibre base here and moves up and down, so there's no way really it can get punctured. It sits really quite protected inside here. When the loop is overinflated, so you've got too much gas in the rebreather, this will be all the way to the bottom. But generally, it's moving around in this kind of orientation right up towards the top. So even if you put your hand inside, you can't really feel the count along either. So it sits right out the way. On the base, we have the overpressure valve. So the overpressure valve is allowing us to exhale water or gas at the bottom base of the rebreather. We usually dive with it in a fully closed position, but as you see, it's just a dry suit inflator. So left to loosen and right to tighten. And in terms of being easy to clean, because we can take it off fully like this, we need to then pour warm water and disinfectant inside. We're going to slosh it around and empty it out. With the JJ count alongs, they're two separate bags. They need to be washed independently and then again drained separately. If you strip the rebreather of the JJ down, it's also easy to clean. One of the things I'll note about this is that when it is wet and you're trying to dry it, it's quite difficult to get the water out all of these little convolutions. So you kind of have to get it upside down, give it a really good shake a few times and a little bit of in and out, and that'll help that water to exit the rebreather. Okay, you can see we have a Delrin piece. The Delrin section is really, really tough and really, really thick. Okay, the Delrin piece is connected with a flange inside this convolution here, and that bolts the count along to the Delrin section, and then at the base with our overpressure valve. What you can see inside is, you can see here, this is a regulator body. So we have a gas feed from our ADV, and the gas feeds along this regulator body. This is a normal regulator body, okay, that you can see in most second stages. And as the count along comes up, I think you can see it, you'll see that there's a little plunger, and that plunger right here, that plunger activates the regulator. So as the count along is compressed, as you're descending or as you inhale, if you've not got enough gas inside the rebreather, when you inhale, that count along will press that plunger, and that plunger will move the lever. By moving the lever, gas will flow through the regulator and enter this chamber here. Okay, so that's how the ADV works on this regulator. Gas is entered here, sits at this spring. When the plunger is depressed, the lever moves, allows gas to flow through, and gas comes out the hole on this side here. Gas then enters this chamber, flows up through the scrubber to the diver. So that's how our ADV works on the SF2. Very, very simple. The manual addition feed is the other nipple that you can see. So this is a quick disconnect nipple. We connect that on to our manual addition valve. So both manual addition valves, remember, come to a single entry point, and that's here. The gas enters and then just comes out a hole. So there's nothing interesting really about that. It's just a tube. That means once we've added gas to our manual addition valve, it float the hose through the hose and out there. So we're inspecting it, make sure it's clean. I can put my finger inside and have a little wipe. Smell my finger, make sure it's nice and clean, looking for any debris, and it's in good condition. The next step is to verify the overpressure valve is functional and it's in the closed position. So to do that, open it all the way, make sure it stops. I'm looking for any bits of softener lime or debris that are caught in there and that the valve moves freely. Close it, give it a little press. Okay. So as you can see, that is my midsection now. Countling's inspected and the OPV is functioning. The next section is to make sure that the O-ring is in good condition. So we have an O-ring here, that's a sealing O-ring that stops water entering the rebreather. So we take a look at that. If required, we get our little tool. Back of a sharpened paintbrush if you like, is a good one. We just lift it out. We can make sure that that groove is clean. This one's quite good condition actually. Looks like Will must have done his job. So make sure the groove's clean. Inspect the O-ring. Again, we're looking for nicks, tears, cracks. Get a little clean on some lint free. That's nice and clean. And then again, a little bit of grease, rub between your fingers. I'm going to grease that O-ring. Again, it doesn't want to be greasy, don't want chunks of grease on there, it just wants to be shiny so that it's greased. Okay, good. Take the worst off. I'm going to flip that onto here. Right, so you'll notice that here is my only O-ring. This is the top part building up the rebreather like this. The base, where the counterlung sits, into the housing, there's no O-ring. And that's deliberate. That's so that the counterlung can move up and down freely, and any water that's inside the base tube can exit through the top. So you'll see that the base has actually got little steps out of it. So it's got little steps out of the base, and that means that any gas that's trapped inside here, when I'm in an upright position, the gas can just come out and leak out. Because in here is exposed to the water. And if I lift it up to show you, you can see we have a hole in the bottom. Okay? So that's exposed to the water, and that means that our counterlung can move completely freely. The next step is to fit the middle section into the rebreather. So I do that, I let the counterlung sag, I'm going to place it so that these two fittings are towards the diver. It's just going to fit onto the base like that. Okay, really simple, nice and straightforward. I'll see if I can turn it around for you. So this is the section, and it just fits down and fits like that. Now the orientation doesn't really matter too much. The main thing is that these two fittings on the back are facing the diver. So I've got that orientated sort of correctly. Now the next step is to fit the upper section. So this is our upper section. The upper section is a carbon fibre tube. Okay. The thing to be aware of is there is a maker's mark, a mould mark here, and that mould mark we change to make sure we fit to make sure that it's facing the diver's back, for no other reason than we like to look good while we're diving. If you look inside the tube, you can see there's a serial mark. Okay, so that's in the coating. There's a mark there, and that tells us which orientation we're going to fit this. So do we fit it this way, or do we fit it that way? The reason being is these are made on a form. To be made on a form, they must be made slightly conical. Okay, so they slightly taper off to get them off the form again. And that means that we need to have it then the right way up. Okay, so we need to have it so that the serial number is facing towards the middle section. So this is our serial number here. It's going to face towards our middle section like that, yeah? So that's how we fit the screw into place. Again, looking for this line. I want to place that on there like that. And a little bit of pressure means that that fits onto that O-ring that we've just greased here along the base. So if I take a look, I want to quickly inspect and make sure that my O-ring hasn't extruded, that it's all in place. So now we've got our base, our midsection with our counterlung in it, our upper section attached to that. And so this space here now is empty. Okay, we're going to tick off that we fitted it. Then we're going to fill our scrubber cartridge. Again, I won't show you how to do that. That's something to learn on the course. But this is the scrubber cartridge on the Scruberforce SF2. The scrubber cartridge is very similar to the JJ. Holds the same amount of line. Sorry about that. So you can see that what we've got in there is we've got a small mesh. Take a look at this one again. You can see we've got a really fine mesh. So whereas the JJ we had big holes and a scrim, on the SF2 you don't need to worry about having a scrim. You can because the scrim is already built in as a steel mesh. Okay. So this is the top section. This is a slightly modified top section, just makes it a little bit easier so we don't lose the wing nut. The normal one has a plate and a wing nut on the top. Okay, this is got the nut built into the spring, so it just means that we can't lose it. We'd fill this with softener lime, fresh softener lime up to the top point, and then we fit our top section, and that then screws into place. The tension's held inside the softener lime using this spring. So a lot like the JJ had 3 springs on the base, okay, and that means that the base of the rebreather was pushing it up, whereas the SF2, the spring is pushing against the nut, and that's what keeps all of the softener lime together. Around the base you can see I've got these 3 parts, and these 3 parts here are what we use to align the scrubber inside the housing in a minute. Okay, something important that I've got, now I've filled that with softener lime, I need to tick it off. An important thing to remember on the SF2 is this O-ring here. So just like on the JJ we have a CO2 O-ring, or at least an O-ring that we need to make sure is in good condition so CO2 doesn't bypass. The same thing on this rebreather. What happens is our gas path is that gas will go down the outside of the scrubber when we exhale, underneath, up through the bottom, through the scrubber, and it will come out through this hole here, and then that is connected directly with this O-ring to the head, and then it will go through the inhale side. So the exhale side comes this side, down the outside of the scrubber, pre-warming the scrubber, up through the middle, and then back round to the diver. This means that this O-ring, if it's not in good condition, the gas that's going down the outside of the scrubber that's got CO2 in it can bypass into the fresh gas. Okay, it's not likely because it's a small place and there is a friction fit, but we do need to make sure that this O-ring is in good condition as well. So what I'm going to do, this is now full with softener lime. I'm going to place this into the top of the unit, okay, and it will fit nice and tight. When it's in there, that top O-ring now, I can just take a little bit of grease. I can make sure that that O-ring there is nice and greased, and then it's in good condition. Just clean off that little bit of excess around the side. Okay, so now I know that that O-ring there is in really, really good condition, and it's ready to accept the head. Take that off. Okay, the next step is to get our head, and I'm going to show you the electronic head of the rebreather now. So again, this will be slightly mirrored, I'm sorry about that. This is the Scruberforce SF2 head. Okay, you can see that we've got 2 ports here that the loop connects to. We have 2 connectors. We have one connector that's a Fisher connector to allow you to connect an off-board device, and we have one that's connected to a Shearwater Petrel 2, okay, because it's a Shearwater rebreather, a lot like the JJ. We have a fitting on the head, and that allows us to connect our oxygen feed, and that's how the oxygen feeds the solenoid. And then underneath the rebreather, we've got our 2 ports. Okay, so as we know, the gas comes up through the scrubber to the centre, doesn't it? And this is the exhale. So the gas will come out here, around the outside of the scrubber, up through the centre of the scrubber, then back up through this hole in the base. Okay, so these 2 points are where the gas flows. The scrubber, the head itself, we've got some little clips on it that allows it to attach to the frame and stay secure. And it's got a single O-ring seal here. This, again, is the same kind of O-ring that you have in this place, and it's just sitting here in the head. I can open the head up for you. To open the head up, you need to put a little bit of friction on and open this. Now this is a really nice part of the SF2. This is the section that connects. This is the section that connects to our scrubber, you see, and so this is going to fit here. So that's our head connecting to our scrubber. If this was to become damaged and cracked, okay, from all of the times that it's been fitted to this aluminium section, okay, and this was scored, there's a chance that gas could pass between the exhale and the inhale side, and that wouldn't be good for us. So SF have designed the machine so that this, I'll put that back so we don't get lost. SF2 designed it so that this can be changed. So this is a really small Delrings part that can be bought very, very easily and cheaply. And it means that without having to send my whole head for remachining or remanufacturing, I can just change this section. Yeah? So by changing this section, I can make sure that I've got a new sealing face between the scrubber and the head. So that's quite a nice design feature. Once I've done that, this base plate here, I'm going to remove it. So you're going to need some nails, which I don't have. So back to my paintbrush. I'm going to remove the base plate to show you guys what's inside. Okay, so this is the inside of the Scubaforce SF2 head. You can see that the solenoid feed is here, okay, and this is our solenoid. The gas flows in, through, and then it's stopped here by the solenoid. The gas goes up and down. There's a little solenoid shutter valve here, and this solenoid moves backwards and forwards and opens and closes the little valve here. Well, it's not a valve, it's more of 2 holes with a seat on them. So what will happen when the solenoid is charged, it will pull itself away, and that will move the valve away, and the gas will allow to flow through. It flows through here, down this tube and into here. So this is an important part to realise. The SF2 injects the oxygen on exhale. Okay, so the gas is injected into the exhale stream of gas. So it injects oxygen into the exhale stream. That exhale stream then has to pass down the outside of the scrubber, mix through the scrubber itself, and then come back to the diver. That's completely different to the JJ. The JJ injects oxygen after the scrubber. Okay, so it's mixed in that mixing chamber before you inhale it. The difference between injection on exhale and injection from inhale is the amount of time the machine's got to analyse the gas, see the gas, and let it mix. Okay, Scubaforce are in the thinking that having the gas mix pre-scrubber means that there's more chance for the gas to mix and you get a more accurate analysis after the scrubber. JJ are in the thinking that adding the gas after the scrubber and then analysing it just before the diver means that you get a more quicker response time between injection and an analysis. So injection and analysis are much closer. This means when you're diving the 2 rebreathers, one of the slight differences you feel, especially during ascents, is that the JJ is a little quicker to respond. You'll feel the gas come in a little bit quicker. Whereas on the SF2, it can be a little bit dumb. If you descend a little bit, the natural PO2 will rise. Whereas the machine's already injecting gas, and then by the time it's mixed, the partial pressure will peak slightly. It's just a tiny bit different, especially when you're changing depth. When you're on a level depth, you don't notice it at all, because the amount of gas that the two machines are doing, they're calculating and they're offsetting it to make sure that it stays as smooth as possible. But in terms of diving the two machines, personally, I feel that the machines that inject pre-scrubber are a little bit slower to react than the machines that are injecting post-scrubber. And that's just a personal thing. I don't know if you guys that dive rebreathers notice the difference, but there's a tiny difference between the two. I definitely notice it, but it doesn't mean that it's harder to dive. What it does mean though is that you need to preempt it a little bit. So with the SF2, you'll know that that little tiny spike I see, and I don't mean a big spike, 0.1 or 0.05, something like that, small spikes that you just kind of breathe through them and you don't notice it. Whereas the JJ seems to be a little bit more stable. But really, both are as effective as each other. So, slight difference. Inhale and exhale gas. We've got our electric set pod here. Underneath this electric pod is our board. Our board contains the Shearwater electronics that our handset talks to. So our handset, again, is just a display. The main control is done by the control board in here. So it's the same control board that the JJ uses for its main control. And that's connected to these three cells, cell 1, cell 2, cell 3. Different to the JJ though, is that in here we only have a single battery. We have a single 9-volt battery, and that one battery runs that main board and it runs our solenoid. Okay, so that's one battery running everything there. We do have a battery in the controller, but if the battery in the headboard was to go down, you wouldn't see anything on the controller. Okay, the difference between this then and the JJ is the JJ has the Shearwater hood built in, and the hood battery is in the head. This is just a Fisher connector. The Fisher connector is connected with giving raw data from the cells. So there's no processing and there's no battery. That means that whatever you connect to here, be it a Shearwater Nerd, a Shearwater hood, or a Fisher connector, a computer like a Ratio or a Henriksfield Camp or another Shearwater, that will give you the raw data. So that it's not processed in any way. There's no other batteries in play. So that your off-board system, again, we've got two separate systems. We've got our onboard system, which is our controller and our main board feeding the solenoid, and we've got a separate system which is a redundant monitoring only system, and there's no battery or anything for that inside the head. Whereas the JJ, to use the hood, we need to rely on the battery that's inside the head. If the JJ battery compartment was to flood, we would lose the handset and the control. Well, we wouldn't lose the handset itself, but we'd lose its data, because we'd lose our feed for our solenoid, and we would lose our hood as well, because the batteries are in the same compartment. With the SF2, if we were to flood the battery compartment, if the battery compartment was to get wet or the batteries to melt, what would happen is we would lose our electronic data from that's going to the Shearwater, but our hood data, our data to our off-board controller, off-board PO2 monitor is likely to still be working. So two independent systems, but with the SF, the system is just raw data coming down the off-board cable, whereas on the JJ, the data is processed on the hood board inside the head. So slight differences between the two again. Personally, I quite like both ideas, to be honest with you. The JJ one, two independent ones, both capable of giving me PO2 data. On this SF though, it means the machine could be a little bit cheaper because we don't need to supply you with this off-board. If you're the kind of person who believes that you dive the rebreather, and if the rebreather isn't working 100% you bail out, then there's really no need to have this off-board monitoring device. Because if anything fails on the primary side, you just bail out. So you could have this then put away. It means that we don't have to give you another more expensive system to monitor with. But if you wanted to, you could have a backup Shearwater to compare across the two systems with. But remember, they're all coming from the same cells. Okay. This base that I've got here has got an O-ring here. There's an O-ring around here, and on the head I have one O-ring around this port. Okay, I'm going to put this back together, making sure all those O-rings are in good condition. Put it on the table to do that. I'll make sure that all those O-rings are in place, and then I can fit here. to the questions we've got. So, Sam asks, how long does it take from the point of O2 addition to mix and be analysed? Pretty much one breath. As you're breathing, you're pulling the gas around the rebreather. There isn't a huge amount of gas stored in this rebreather. If you're on minimum loop, which is the smallest amount of gas you're supposed to have, the normal amount of gas you're supposed to have in the rebreather, if you're breathing normally, you can inhale and exhale, and you've completely emptied the rebreather full of gas, which means you'll have moved all the gas around. So it doesn't take long at all. It's kind of when you exhale, the gas is going to pass down. That gas is going to be then have oxygen added to it. As you inhale again, most of that breath is going to come back up through the scrubber, and you'll probably take what was sitting in the top half of the scrubber first, but some of the gas will then be mixed and pulled up into the cells. So it's pretty much instant on every breath, but it is a lag compared to on the JJ. Are the JJ hoods interchangeable with the SM2 hood? No. So the JJ controller is, so I can change the handset. This is called the controller, this part here. Okay. And this is using the exact same connector inside this fitting here. This is just a small cover under the two O-rings. I can unplug this connector. This is a controller fitting. So that's a Shearwater dive can. Okay. So I can plug the same controller into there, so that's not a problem. But on the hood side, no. On the hood side, for the JJ, you've got a dive can connector as well, because you've got electronic monitoring board inside the head. With the SF2, the off-board monitor plug, so our off-board monitoring plug here, is not a dive can connector. It's a Fisher connector. I don't know if you can see that. Okay, and that's a Fisher connector. Fisher connectors are standard on a lot of dive computers though, so you can plug it into a Shearwater, you can plug it into whatever you like. You can actually get a Fisher connector Shearwater hood. So the same hood that's on the JJ, you can get, and it comes down the hood cable, and then there's a little box. The little box contains the battery, and it contains the controller board. You then plug the Fisher into that box, and then effectively, you'll have exactly the same looking system as the JJ, but it won't work in the same way, but it looks the same. So you can have a Shearwater hood, which is what the JJ is fitted with, connected to the SF2, but it works in a slightly different way. With the counter lung next to your arse, what's the work of breathing like if you're flat in the water? So, if you're completely flat in the water, the static load on the rebreather is slightly negative because it's slightly above you. With all rebreathers, the best bet is to dive slightly out of trim anyway, kind of 5, 10, 15 degrees out of trim is really quite natural and normal. And that means that your arse is relatively level with your lungs anyway. And so the work of breathing then feels really, really nice. A lot of people have told me that this is the easiest rebreather in terms of work of breathing. They feel that it breathes the best because you can dive slightly out of trim. With some of the other rebreathers, like for instance the JJ, if you go slightly over trim, the gas moves to the back of the counter lung and it becomes difficult to breathe. But in completely flat trim, the JJ breathes really, really nice. With all rebreathers, if you go completely upright, the breathing isn't perfect, okay, because it doesn't feel as natural and normal as it can. The gas has got to go up here through the T-pieces and stuff normally. There's SF2. When you are completely upright, either on the surface or if you go completely head first underwater, this bellows counter lung is affected. So if you're upright, the bellows is at a much higher pressure than your lungs, and that means that the water pressure is forcing that bellows up, and that means that the gas feels like it's being pushed into your mouth through the loop. So if you're completely upright, breathing from the rebreather on the surface with the loop open, you'll feel like a little bit of hamster cheeks because there is positive pressure on that gas. Same thing, if you turn completely upside down on this rebreather, that bellows will be then pulled up, okay, and it kind of dragged, and that will feel like it's sucking air away from you. So completely head down and completely upright, there is a breathing difference or a breathing resistance. Now, it's not something that you can't breathe through. I would dive this in a cave. I can go head first, up, down, left, right, without any issue at all. One of the things we do on the course with this rebreather is we get people to try it in different orientations. So on their back, on their front, on their side, head first, upright. And you do notice a slight difference, okay, with how it feels. But when you're diving with it in the normal position, which is kind of, let's be honest, like 99% of the time, it feels absolutely perfect, and the work of breathing is very, very neutral. So it's just a case of understanding that if you're moving out of position, which positions does this rebreather not like? For instance, if you dive with a Poseidon with a front-mounted counterlungs, if you turn onto your back, it really doesn't feel like that, very nice either. So each machine has its own place or position where the breathing is out of standard. And that's normally written in the CE test file. So the CE test file will normally say that the machine breathes in this position and this position, this position, and that this orientation or this orientation are not inside the test parameters. Okay, so they're not normal position to dive in. So diving in the normal diving position breathes perfectly. When you're on the surface, little bit of positive. When you're upside down, completely little bit of negative. But I thought it'd be much greater than it actually is. When I first dived with the machine, I was a little bit apprehensive about going head first or being up around the surface, and I did kind of tend to think to myself, how's that going to feel? But I didn't really put much thinking into it after I did it the first time. Another thing to think about though is oxygen being injected before the scrubber means if you come to the surface and the PO2 in the rebreather is below set point and you go off the loop, gas will keep being added at the top of the rebreather, nowhere near the cells. So that means that the loop will fill up and eventually the oxygen will come out to the bottom through the pressure valve and it will never reach the cells. So one of the things you always need to remember with the SF2 is when you're breathing from the rebreather and you want to go off the loop, make sure that the PO2 is over set point, and that way it won't inject. Okay, so again, slight difference between the JJ. With the JJ, any point you come off the loop, the solenoid is injecting right next to the cells, so it'll inject and the cells will come up to PO2 and it'll be stable very, very quickly. I bet you it's lovely side mounted. It is very nice side mounted. However, with all side mount rebreathers, the configuration is the main thing. If this machine is slightly up or slightly down of your body, the breathing changes quite dramatically in side mount. Especially as side mount, you are so able to be dynamic, you know? And that means that with this here, bolted rigidly to my hip, it's in a very nice kind of position with my lung. My lung and the counterlung are in a very similar position. However, if I let that happen slightly, which this wants to do because it's full of gas, let it lift up slightly, now you can see that a good portion of the counterlung is much higher than my own lung. And that means that it becomes a little bit more difficult to breathe from. So with the side mount rebreather, it really takes a lot of setup to make sure that the machine doesn't move while you're diving with it. Okay. So, what we need to do, according to our checklist, is observe the solenoid firing at least 3 times and verify the battery levels are sufficient. So, I'm going to turn on my controller and check my battery levels. The reason to do this now is if I'd already fitted the head, I'd need to remove it to change that battery. So I'm going to check the battery levels right now. To do that, the solenoid needs to fire. With all Shearwater computers, I don't know if you guys can see this, what you'll see there, it's on the external battery voltage, I've got a question mark. It can't read the external battery voltage until the solenoid's fired a few times. Once the solenoid's fired a few times, the board inside can detect what the voltage is. So now if I go to my voltage screen, I can see that I've got 7.7 on my external battery and 3.46 on the battery that's internal in the handset itself. 7.7 and 3.46. So the numbers that need to be above is 6.6 and 3.3, and they both are. So I can turn that off and save some battery. And I can tick that. Make sure the sensors are dry and connect the bottom plate. So we check the sensors. Let's open up again so you guys can see where they are. So these are our 3 oxygen sensors, sensor 1, 2 and 3, and they're held underneath this plate. So to remove them, I'll remove the cables and I'll undo these 3 Allen key bolts and the 3 cells will come out. Where do the cells sit? If you look here, okay, this rebreather opposite to the JJ. So the JJ is you exhale to the right. On this SF2, you exhale to the left. Okay, so when we exhale, the gas is going to come through here and out through this port here. So you can see my finger on the inside there. When we inhale, the gas comes up through here, and here I can feel my cells. So on the inhale, when I inhale, before the gas comes to the diver, in here, you can see my finger again, look, on the inside. You can see my finger disappear into the cell hole. So as I inhale, the gas goes onto the sensors and then comes back to me. So this is my exhale side, and this is my inhale side. Again, it depends what you believe. Some rebreathers have a right to left loop, like the JJ, the Inspiration, so that you inhale from the right hand side and exhale to the left hand. Sorry, you inhale from the left hand side and exhale to the right hand side. Whereas the SF2 is the other way around. The SF2, you exhale to the left and you inhale from the right. Now, partly comes from the old additive that rich right, lean left, means that the rich gas is coming from my right and the deoxygenated lean gas is going to my left. So that's how the SF2 is designed. Whereas the JJ and everything is designed a little bit more how you would think as a human. So what that means is we kind of read left to right in most European places. So that means that left to right kind of makes sense, that that it's coming this way and the gas is passing left to right. Doesn't really matter how the machine's designed, as long as it's designed in that way. But it does mean that you need to think about it when it comes to doing stuff like the different skills across the machines. You need to know whether the machine's right or left. If I wanted to drain the spit that was in my mouth out the JJ, then I would lift the hose and tilt it towards my left hand side, straightening that right hand hose. Whereas I want to do it on SF2, I need to lift it up and push it over to the right because I'm straightening the left hand hose to make the water go away. So a little bit of difference between the two. So I'm going to pop this now back into place. Make sure the O-rings are in. Fit that. Verify the sensors are dry and connected and the cover plate is down and the O-rings are in place. Yes. I'm just going to check the big O-ring here. This O-ring is our sealing face on the top of the rebreather. So I'm going to take that one out. Use my tool. Pop him in there. Clean out the groove. A little bit of sand in there actually from the last time I went diving. Nice, clean out. Clean the O-ring. Inspect the O-ring if we're looking for nicks, grooves, tears, cracks, etc. And then I'm going to grease it back up again. Now this O-ring here, I actually grease this one a little bit more than any other O-ring. Because the head comes off quite a lot from time to time, especially when I want to dry it, I want to be able to get the head off whenever I want to. So if this one's a little bit tight, it just makes it a little bit difficult to get the head off. So I'm going to put plenty of grease on there. Fit that into place. Just have a little tidy up. Okay. So, fit the head to the middle section, confirming the head is aligned, and put the clips down. So I'm going to place it on top of the package that I've got so far, and I'm going to align it so that these clips on the side are in place. So if you can see there, so I'm going to align it so that these clips are in place. One of the things about these clips is they hit the cylinder. They're designed like that. The clip can't accidentally come undone while the cylinder's in place. So I'm going to line my head up, make sure that it's all in place. And then I'm going to push down slightly, make sure my O-ring stays in, put one side, and then on the side, just a little bit there. Okay, cool. So now my head's pushed down flat. I need to release the cylinder slightly to allow this clip to go on. Then I can put my cylinder back on. Same thing on the opposite side. Release the cylinder for a moment, put the clip into place, and then snap it down. Put my cylinder back on. So my head's now fitted to the unit. I mentioned in the last video, the cells include cables. Correct. So, on the JJ, every time you change the cell, you get a new cable. On the SF2, every time you change the cell, the cable remains in the head. If you damage the plug or you damage the cable, it means the head has to go to the service centre to have the electronics open, have a new wire soldered on, and then have those electronics potted in compound again so that they're sealed from the elements. So a little bit more difficult if you snap a wire on the head of the SF2 compared to the JJ. A bit of grease on there, look, clean it up. So we're going to go now and fit head, that's done. The next step is I need to verify my regulator in stage pressures. So I'm going to turn it around so you can see what we're doing. Turn the machine around. So you guys can see everything. Okay, I'm going to verify the in-stage pressure of the regulators. The reason to verify the in-stage pressures on the regulators is the same as the JJ. If the oxygen regulator is too high, because the solenoid is an upstream valve, it has to open against the flow of gas. If the gas pressure is too high, you use more battery voltage, or the solenoid won't be able to open at all. On the diluent side, it could be too high and make the ADV free flow, which is not what we want. So we need to make sure that our in-stage pressures are low enough. Also, another factor is that we want to make sure that the in-stage pressure is lower than the off-board pressure. So our off-board regulators, so our bailouts, are going to have an in-stage pressure around about 10 bar. And that means that our on-board regulators I'm going to set to around about 7 bar. And that means that if I plug in an off-board gas, the off-board gas flowing into the hoses will push back the on-board gas. So it will be the off-board gas that I get. Because I've deliberately plugged in off-board, that's what I want to get. I don't want to get a mixture of the two gases, and I don't want to plug in off-board and only get on-board. So I want to make sure that if I plug in off-board, it's off-board gas that I'm going to get. So the in-stage pressure in the regulators off-board is higher than the in-stage pressure of the regulators on-board. Okay. So to do that, I'm going to need a fitted, because this rebreather comes with the special quick disconnects that you can see here. That's not a low pressure inflator fitting. So I'm going to use this. This is our calibration hose. You use this anyway to calibrate the rebreather, but it's got one of the Scuba Force quick fittings on it, which has got a one-way valve built in, and it turns it into a normal low pressure inflator fitting. So the first side I'm going to do is my oxygen side. I'm going to turn on my oxygen regulator. Again, try to go for as close to 2 minutes as you can. So I'm going to cover the gauge, just bring up the gas supply a little bit. Okay, so we're at 10 bar, tiny little bit slower now, so we're at nearly 50 bar now. We're going to wait, kind of bring it open a tiny bit more. We're now at 70 bar, coming up 80 bar, 90 bar, coming up, and then, okay great, we're at 200 bar now on our oxygen side. I'm going to plug in my in-stage pressure gauge, turn that on. These are really nice pressure gauges, by the way. These are the digital Pandora in-stage pressure gauges. You can grab these on our website. Really, really easy to use, super lightweight, just fit in your bag. Just change the battery. We're going to put that connector on, and then we're going to plug in our IP gauge. Okay. And the in-stage pressure on that regulator is 7 bars. So 7 bars, that's perfect. Disconnect it. I'm going to do the same thing now on my diluent side. Put it into my diluent side. Turn the gas supply on my diluent side. And then again, plug in and verify my in-stage pressure. And my in-stage pressure on this side is also 7 bars, good. Disconnect that. So now I've checked that my in-stage pressure is correct on my oxygen side and on my diluent side. Now, I want to now connect the manual add fittings. So I've got one manual add, sorry, the two fittings for my ADV first. So the ADV feed is going to fit into this section here, which is the regulator that we saw, the second stage regulator part that we saw inside the main middle section. And I'm going to connect that with a quick connect. So just push those two together and then lock it into place. I'm going to do exactly the same thing with the feed from my manual addition valve. So my two manual addition valves, the feed comes into one, and that's going to connect there, and I'm going to lock that one off as well. So now the two manual addition buttons, if I add gas to those, that gas flows through the manual addition button and then into the rebreather here. Our ADV comes directly from the first stage directly to here, and they're both switched off. So now I've connected the manual feed and the ADV. I can tick that off. So now it's time to calibrate the rebreather. With the JJ has an auto calibration procedure. Because the solenoid is next to the cells, I can ask the solenoid to fire, and the solenoid will run and flush those cells with 100% oxygen and allow me to calibrate. Like we spoke about with this rebreather earlier, if I inject oxygen, oxygen is going to be added to the exhale side, which means it's going to go down the outside of the scrubber and outlet over pressure valve, and the oxygen will never reach the cells. So I can be adding oxygen, then my cells will never come up because there's nothing moving the oxygen around the rebreather, which is normally you. You're normally connected to it, breathing it. So to calibrate this rebreather, I need to use a calibration kit. Okay? To use a calibration kit, this is what it looks like. It consists of 3 parts. I have one fitting with an inflator nipple on it. I have another fitting without an inflator nipple on it, and I have my calibration kit hose. Right? So I've got the calibration nipple, and I've got the one without the calibration nipple. I want to put oxygen directly onto the cells. So if you remember, the oxygen cells are here. They're on the inhale side. So I'm going to fit this, just screw it on to the inhale side. On the exhale side, just to make sure that any gas can't enter and to slow the gas flow down, I'm going to fit the other one. So I've got my calibration kit fitted now. So on one side, I've got the one with the nipple. That's on our inhale side. On our exhale side, I've got my just flow restrictor, basically. Then I'm going to turn my electronics on. Turning my electronics on, it's going to be the same as you see on the other rebreathers. And I want to go, using the menu, to the calibrate screen. If I open the calibrate screen, it's going to give me my current cell millivolts in air, because that machine's been exposed to air now, hasn't it? And there's not been any oxygen added. So I'm going to write down my cell millivolts in air. So that's 11 millivolts for cell 2 and 11 millivolts for cell 3. Cell 1, cell 2, cell 3. And they're PO2 of 0.21, which means the calibration last time was good. And the calibration gas I'm going to use today is going to be 100% oxygen. So I'm going to write down my air millivolts, which is 11 for cell 1, 11 for cell 2, and 11 for cell 3. Okay. Now, this is a manual calibration process. So what I need to do now is I need to put oxygen in here manually. Okay. Bring those cells up to pure oxygen. When those cells, I'm confident, are at pure oxygen and the cell values have stopped rising, like you do when you use an analyzer, and the cell values are stabilised, then I can tell the machine, yes, that's pure oxygen, and I would like you to calibrate. So to do that, I take my oxygen feed, which would normally be plugged into the solenoid, and I plug in my calibration kit. The calibration kit then plugs in to the top there, and that plugs on. And what you can see has happened, just that little bit of oxygen, turn it back on again, just that little bit of oxygen that was added that was remaining in the hose, go back to my calibrate screen, that little bit of oxygen that was in the hose has brought the cells up to 50, 48, 48, 48. So almost to pure oxygen already. So what you're going to see me do now is I'm going to open the valve slowly and let some gas flow. So oxygen's flown inside the rebreather now, and it's flown directly onto the cells. You'll see the millivolt reading start to rise. If you were doing this for yourself, you wouldn't waste so much oxygen as I'm doing now. I'm just going to waste a bit of oxygen so I can show you what's happening. You can see this millivolt readings are coming up, and much like when you use an analyzer, you need to wait for those millivolt readings to stabilise. Based on my last calibration, 100% oxygen on cell 1 is still 100%, so that's good. On cell 2, it was slightly out now, isn't it? You can see that the calibration, even though this is pure oxygen, it's at 1.03, so like 103% oxygen. So that's wrong. So that one needs to be calibrated back in again. And you can see that cell 3 has drifted slightly as well, and that's slightly under. Even though this is pure oxygen now, it thinks it's only 98%, or the equivalent of 98%. So I'm going to go back to my calibrate screen, make sure my oxygen's flowing, make sure my cell readings are stable, and when I'm ready, I'm going to press the calibrate button. And you'll see I've got calibration success. Fraction of oxygen, 1. Adds an ambient pressure, so surface pressure of 1, means the PO2 should equal 1. Cell 1 was 52, cell 2 was 51, and cell 3 was 52. So 52, 51, 52. I'm going to write that down. 52, 51, 52. And if I press confirm, you'll see now my machine is completely calibrated. 1, 1, and 1, all with pure oxygen. To save my oxygen supply, I can just now turn that off. So what I've done is I've calibrated the machine 1, 1, and 1 with pure oxygen. If I had a backup computer or Nerd, whatever, connected to this Fisher, in the same way, I would calibrate that. Okay, so what I'm going to do now is I'm going to go and turn this to surface set point. If I go through my menus, I have a set point, which is 0.19. And if I put that one on, that means the set point goes to 0.19. The set point is what the machine is trying to achieve. So if I breathe from this rebreather, the oxygen will come down and down and down. As soon as it reaches 0.19, that solenoid will fire. Okay, I've set it like this because 0.19 is less than air. Air is 0.21. So that means that as I'm working now, as I'm taking bits off and fitting other bits, the solenoid will not fire because the oxygen in the rebreather will never go below 0.21 because it's air. It's only if I'm breathing from the rebreather can I bring the PO2 down below 0.21. So while that's happy, I can just leave it on surface set point mode. My next step is to remove the calibration kit and connect the solenoid feed to the head. So I'm going to remove my calibration kit. I'm going to take my solenoid, quick connect, I'm going to push that onto the head, and then I'm going to tighten that one. You can see these fittings are really easy to tighten, and now that's super solid on there. With that, as soon as I unscrew the lock, it comes off very, very easily. But once I've got the lock in place, it's really, really solid. I quite like these connectors actually. I'm not a big fan of having anything that's not required normally. I would normally just like a solid fitting. But these fittings are really high flow, they connect very, very easily, and they don't allow water to enter, so they've got one-way valves in them as well. So we're really quite happy with them. Connect solenoid, feed to head. Done. It's now asked me to open the oxygen and open the diluent fully. So I open my oxygen slowly. Diluent I'm going to open. Oxygen slowly. Okay, and then I'm going to open those cylinders all the way. I need to verify that both manual addition valves are functioning. So I take my manual addition valve for the diluent and I'll check it's working. So add gas, nothing happens. Check this isolator. Add gas, gas is added. Check the isolator goes off. It stops the flow, turn it back on again, check it again. So my diluent side, manual isolator, manual addition valve working. Oxygen side, same thing. Add gas, isolate the flow of gas. We don't get any gas, turn the flow back on again, and we get gas. So we've confirmed the MAV's working and we've confirmed the isolators are both working. You'll notice a difference in sound. If I press the diluent, quite loud, lots of gas flow. If I press the oxygen, much quieter, less gas flow. There's a restrictor in here. This means that underwater at depth, if you lean on this button or you press this button too hard, you're not going to get a frightening amount of oxygen. On the JJ, both buttons work the same. If you press the oxygen button too hard, you'll get a lot of oxygen in one go. So just a case of Scuba Force has decided to fit a restrictor in there just to make sure you don't add too much oxygen by mistake. Both mouths are functioning correctly. Now I'd verify that the wing, inflator and dump function. So I can't do that because my wing's not fitted. So we'll put an X in that box there. Next step is to take my loop. So this is the loop of the SF2. The loop of the SF2 is really tough. So it's made out of a very tough, durable rubber, very, very strong. It's got loop weights on there. Those are these metal things you can see. Those loop weights are designed to stop the loop floating, a lot like the ones on the JJ. And then I've got a DSV. So no BOV available with this, DSV only. And the DSV operates by moving this lever into the closed position or bringing it up into the up position. So I have a closed position and I have an open position. The mouthpiece is the Scuba Force mouthpiece that's fitted with a really tight cable tie to make sure I don't get any water through there as well. So both sides come down to hose ends. Each hose end inside there has an O-ring. I think you can just about see it. Those O-rings need to be inspected, cleaned if required, and I'll also, I'm just going to put a tiny bit of grease on there as well to make it easy to fit. Now, what you can see is if you look at the two, you can see that this one has a slightly smaller diameter than this one, okay? And that means that this side and this side can't be fitted the wrong way round. It can only be fitted the right way round. So it's interlocked to make sure that I don't get the gas flow the wrong way. Because like the JJ, inside the mouthpiece, here and here, I have a set of mushroom valves. And the mushroom valves work to open, allow the gas to flow, and then when you exhale, they close again. Remembering that the gas flow here is inhale from the right and exhale to the left. So the mushroom valves are opening in that direction, let gas flow in that direction there. Okay, so one here and one there. And the gas moves in this direction. So I need to make sure that those mushroom valves are working. Same way that I did with the JJ, I'm going to open the loop, I'm going to put the loop into my mouth, and then I'm going to cover one side while listening, not covering, but listening to the other side. So if I'm going to cover my inhale, okay, this means that I shan't be able to inhale, but I should be able to exhale. Okay, that's great, that works. Now I'm going to check the other side. So I'm going to cover the exhale side, push it against my cheek to make sure it's completely sealed. I shouldn't be able to now exhale, but I should be able to inhale. So don't blow too hard. Again, I only want to blow a normal amount, just like I'm working the mushroom valves normally. And that means that now those two mushroom valves in there I know are working. The gas is going to move around the rebreather. The big issue with these mushroom valves failing is that the gas doesn't get moved around the rebreather. You'll just breathe and the gas will just fill the hoses and go back into you. So the gas won't go through the rebreather. That means that CO2 won't be scrubbed and the oxygen won't be added. The gas will just be pendulum in the mouthpiece. So if these two fail, then you've got a bit of an issue. So this is our loop. Verify the correct operation of the mushroom valves in the mouthpiece, check the loop hose O-rings, and connect to the head. So you can see, I'm going to connect here, the loop, one side, connect the other side. I'm going to have a little look at the orientation. So again, the mouthpiece here, I want pointing directly up. So it sits pointing upwards. When I'm happy, I can then go ahead and tighten these fittings. Again, like all fittings on all rebreathers, don't over tighten them, just take them till they stop. Everything's designed to have O-rings on. The fitting itself isn't stopping any water going in, the fitting's just keeping it all together. So the fitting can just be taken to the stop. Okay, we'll tick that off on our checklist. Next step is to verify that the dive surface valve, the DSV, is functioning correctly. So I'm going to move it into its open position. look inside, make sure that it's clean, free of debris. I can check it with my finger, make sure that it's clean, open and close the loop, make sure that everything is working as it should. There's no grit, there's no grinding, there's no stones, that kind of stuff caught inside my loop, which I'm happy about. Now, I'm going to close both cylinder valves and perform a high pressure leak check. Okay, so with this, the rebreather is on and it's in surface set point mode. If the solenoid was to be passing now, okay, I would lose some gas flow. So I'm going to turn off both cylinder valves. I can take a look at my two manometers, two SPGs, and see that I have 200 bar on the diluent side and 190 bar on the oxygen side. And they're both going to sit there. 1 minute's time, I'm going to open the valves again. If the needles flick back up, that means that I've lost pressure during this 1 minute. And where's that pressure gone? That's what I need to know. That pressure shouldn't be leaking through anywhere. All the system now is fully assembled, so there should be no gas entering the rebreather. If gas is entering the rebreather, it might be oxygen, and that's bad. If it's diluent, that means that when you dive in, more oxygen will be added, and that's bad. So we need to make sure that our hose integrity on the high pressure side is good. So got to make sure that those now are waiting for 1 minute. When I'm ready, I'll come to my oxygen side, turn the valve back on. Okay, there's no jump in the needle. That means that that oxygen side is perfect. On the diluent side, same thing. If you look, I've got 200 bar. When I open the valve, the needle doesn't move at all. Yeah, and that means that the diluent side is also fine. So diluent side and oxygen side, both working great. I can tick that off. The next step I'm going to do is I'm going to perform a negative test on the rebreather. So a negative test, like on the JJ, like on other rebreathers, we're going to design to be able to pull and compress everything, make sure all the O-rings are under compression, the counter lungs are under compression, and make sure that any of our, let's say, overpressure valves aren't leaking or jammed open. So to do that, I'm going to need to make sure that I close my ADV feed. If the ADV is on, whenever I inhale, I'm just going to get diluent. If I exhale through my nose and inhale through my mouth, that lever, that counter will come up, hit that lever, and that lever will fire. So I need to make sure that I turn my ADV off. I'm then going to perform my negative test. To do that, open the loop, inhale through the mouth, exhale through the nose, and repeat. Okay, and what you can see there is the loop is contracted right up. Okay, if the loop was to be leaking, what would happen? You would see this. You see the loop expanding and sagging. That's because there's a loop leak in the mouthpiece. It's because I actually opened the mouthpiece. So we'll do that again. Okay, we're going to perform our negative test for the minimum of a minute. I'm going to see if this loop sags, and when I reopen, is there going to be a sucking in of the air? You've got to imagine now that that counter has come right up. All of the hoses are compressed right down, so they're under suction. And whenever they stay there, the loop is quite good at maintaining that that suction. It means there's no leaks. So we've got it there. We wait for a minute. After my minute, I open it. I should be listening and checking. There we go. So that was quite a good negative test. Okay. Now I'm going to do a positive test on the rebreather. To do a positive test, I'm going to blow the rebreather right up, make sure that the counter lung that could have been stuck together with a hole in it is going to be completely expanded. All of the O-rings are going to be at their expansion points, and all of the overpressurization valves are going to be tested. Okay, so to do that, I need to lay the machine slightly forward. If I don't lay the machine slightly forward, what happens is the counter lung will expand, and the OPV will hang out the bottom of the rebreather and press on the table. The OPV pressing on the table means that it'll activate, just like it does when you pressurize your dump valve. So I'm going to lean the machine slightly forward. Okay, so I'm laying it on its front. Okay, and I'm going to do a positive test. This means blowing the rebreather up. So I'm going to inhale through my nose and exhale through my mouth. Okay, so I've just felt gas come out the back of the machine. The overpressurization valve connected. So now it comes to the base, and I just press around the edges of the OPV on the counter-lung, and I can feel that that is completely solid. Okay, what I'm going to do now is wait 1 minute, and this should be as completely solid in a minute's time. That means that the machine is now integral against expansion as well as contraction, so positive and negative. While we've got a minute, I'll just answer a few questions. Would it be possible to rig the SF2 in a similar way to the GUE version of the JJ? Yes, absolutely. So there's no reason that you can't put the big cylinders, manifolded diluent and long hose configuration onto this rebreather as well. A lot of people like this rebreather because you don't have the counter-lungs. The counter-lungs are built into the tube. So it means if you were going to go for a bigger design, so to put bigger cylinders on or more regulators, it would be easy to access things like the valves because you don't have to worry about T-pieces or counter-lungs on your shoulders. So potentially, yeah, this is actually this very similar design to the Halcyon RB80, so which is a PSCR, a semi-closed rebreather, that's a tube, the same as this, not carbon fibre though, that fits inside a set of doubles. And then you use a lot of off-board gases and gas blocks to run the rebreather as a semi-closed rebreather. But that's where the design for the GUE JJ came from. So the GUE JJ was kind of based on the Halcyon RB80, and the RB80 is kind of similar design to the SF2. So yeah, there's no reason that the GUE type configuration can be fitted to the SF2. Although as far as I'm aware, GUE don't authorise the teaching on the SF2. The teaching of the GUE course is only on the JJ. Next question. It looks like the rings are recessed and quite protected. I guess we're talking about the O-rings on the hoses. Yep. So they're protected quite nicely inside the fitting, just like all rebreathers. In fact, it's a bit of a pain. Most rebreathers, the hoses, where they fit together, they have an internal that fits inside an external, then a thread that goes over the top. And those O-rings are then well protected in there. They're protected against being on the floor in dirt, but they're a bit of a pain to get out and grease. On the JJ there's two. The first one's easy to get to, the second one's a bit further and deeper in. That's hard to get to. On the SF2 we only have one O-ring, so it's much easier to get in and out. One of the things that I find quite difficult to get out is, for instance, on the Poseidon, those ones you have to push the cover over and get those out. So each machine has its own, but none are all that easy to access in the hose, to be honest with you. Any more questions? No, so I think that's it for now. So I'm just going to check now after 1 minute that my counter-lung here, that's nice and solid. So I can't push that counter-lung, I can't contract that bellows at all. That is completely solid and it's in the same position I had when I did the positive a minute ago. So just to check, I'm going to open OPV, the DSV, sorry, and so I hear that, and that was my counter-lung contracting again. I'm just going to push the counter-lung up, and then I'm going to stand the machine back up again. Good, so we've done our positive test, we've done our negative test, and both have passed. Take that off. My next step in my checklist is to verify that all gas isolators are open. So we closed the isolator on the ADV. So I'm going to open the ADV gas isolator. I'm going to check the gas isolator on the solenoid is in the open position. The way to remember it is if it's down towards the first stage, that's shutting the gas. If you pull it away and with the gas flow, that means that it's open. I'm going to check the sliders here, the gas isolators, on my MAV as well. So same thing, if I go against the gas flow towards the first stage, that's off. If I go with the gas flow away from the first stage, that's on. Same thing on my diluent side. They've actually got little on and offs if you want to take a look, but you don't need them. With the flow of gas, against flow of gas, off. With the flow of gas, on. So I have 4 gas isolators. One for my solenoid feed, one for my diluent feed to the ADV, one for the oxygen MAV, and one for the diluent MAV. And they are all open. Next step is to route the controller. So I put the controller down my left hand wrist, I wear this on my left. If I had my backup, I would put that down my right hand side or onto my hood. pre-breathe for at least 3 minutes. So I would do a pre-breathe exactly the same as I do on the JJ. Again, we're doing our pre-breathe to make sure the machine is operational, make sure that it's capable of sustaining life, not necessarily to check for CO2, although you do want to monitor yourself for signs of hypercapnia. So we do a pre-breathe on the surface to make sure the machine is functioning properly. Verify that the PO2 on the controller and the backup is fitted match. And then I can switch off my rebreather, turn off the gases and turn off the controller. And that will be my complete build-up. So I'm going to show you now adding the wing and harness just to make sure that it's all nice and neat together. So put the loop over the top, put my mouse over the top, and I'll put my SPGs also just under the loop out of the way. Take off these two connectors. Needs to go that way, sorry. We'll take off the two wing nuts. One there. So wing nut and a washer on both sides. I've got a wing. So this is just a 45-pound donut wing. So I'm going to fit a 45-pound donut wing into place. I then get my back plate, and again, same as any other back plate, nothing special about it. I'm going to fit a washer, and I'm going to mount my wing nut. Washer again, wing nut again. Okay, so now I've got my back plate and my harness fitted to the rebreather. Whereas the JJ, they've got the counter rungs sandwiched in between the two, and the counter rungs are connected to the harness. The counter rung in this machine is at the base, which means you're really free. That's just like wearing a twin set harness and a wing. But we do need to make sure that we can access the systems. So I'm going to put my two feeds. So I've got my SPG and my manual addition valve. They're going to come over the top. To do that, I've got a little piece of rubber, like not rubber bungee. Just fit that through there. On my oxygen side, I've got a little tighter one here just to keep it really in place. Excuse me while I just fiddle with that. Obviously I need to make sure that none of this interferes with my slider. So now I've got my manual addition valve through my harness. I also, on this rebreather, will put my SPG over my shoulder. So it's not a normal thing I do. I usually have the SPG on the clip on the left hand hip, but I find that because I don't have to worry about having a counter on here, having the gauge over the shoulder like that means I can just lift it up and I can see it quite easily. So that's my oxygen side completed. I'm going to do the same on my diluent side. So I've got SPG, and I've got a manual addition valve. Manual addition first. Through the bungee, then through the little bit of inner tube that we've got. Same thing, I can pop this SPG through as well. finger around so they're neat. Put that through there. Put that through there. So now I've got manual addition and an SPG on the Dylant side, manual addition and oxygen on that side. I do need to, of course, put the feed for my wing, so I'll make sure that I'll do that. Feed for the wing, and that feed is going to come over the top and sit through this little piece of bungee here. That one there. Down a little bit. Okay, and so this is my harness. My harness is an adjustable harness. Again, it means that I can just tighten the harness up if I'm wearing a different undersuit to get the rebreather position right. Having a rebreather not on your back in the right position feels quite nasty, so trying to get it in the right position. And then we've got the loop, and the loop will come over the top, like so. So without the loop on, other than the fact that you've got these two gauges on your shoulders, you don't really notice that you're on a rebreather at all. There's no T-pieces, it's very easy to move your head left and right. A contrast to the JJ is that in the loop hose here, we've only got two fittings. We've got the fittings at the DSV, and we've got the fittings on the head. In the JJ, we have our T-pieces in between, so the fitting into the T-piece and the fitting out the T-piece on each hose as well. So we have twice as many fittings on the JJ hoses as we do on the SF2 hoses. This means that this hose here is quite flexible, look. I can move my head very easily left and right without having to push against the two T-pieces that are on my shoulders. Okay, so that is how the loop will kind of sit in your mouth like that, and then you'll move against the loop. Okay, a couple of questions. It looks like potentially a bit wobbly, balanced on the edge like that. I like the look of the JJ because of protection of the valves and stability unit. Are we talking about the stand, Sam? I think you're talking about the base, right? So on the base of the rebreather here, the rebreather stood up on a dowel ring section that's designed to have the rebreather stood up. Okay, if you look, it is quite, sorry, shaking the camera all over the place, it is quite functionally stable. It isn't going to fall over at all. It's designed to be like that. But you can buy a foot that fits on it with a frame shaped exactly like the JJ frame to lift the machine up slightly and to protect those first stages. Well, if you look at the protection of the first stages, look, they're quite well protected. They're off the floor, they're between the valves and the wing, so there's no reason that they're going to get knocked either. So everything's well protected. Is there an option of MCCR with this? So no, there's no option of MCCR except for not plugging the solenoid in. The SF1 you could get in an MCCR, but the SF2 is ECCR, so electronic. But there's no reason you couldn't blank off the solenoid if you wanted to, but you'd still have to buy a full machine. Is there a lifting handle? Yeah, so we have a lifting handle attached to the rebreather. So if I lift the loop away, you'll see here I have a handle, and that handle allows me to pick the fully assembled rebreather up and move it around. Sitting on a rib, you sit on the rib just like it is here. So the rib is onto the base of the rebreather. The valves and stuff, you're not going to touch those at all. They're inside the streamlining of the machine, so they don't stick out past the cylinders particularly. And when your wing is around, they're not exposed either. So really quite protected in terms of the valves and first stages. Tom, nice to see you, mate. I know it's Tom Jaspers has joined us. Everybody like to say hi to Tom. Tom is the designer of the SF2, as well as the owner of Scuba Force, the company. So good morning, Tom. I hope I'm doing you justice here. I've not seen you trying to get back on a rib. Yeah, so best way to get back on a rib, don't dive off a rib. Get yourself a hard boat. Hard boat with a lift preferably. But no, very easy actually with this rebreather. As you can see, the rebreather is really, really compact. That means that there isn't a lot of buoyancy. Because it's lightweight as well, means that you don't have to have so much weight when you dive in this rebreather. Both me and Will, with steel backplate and steel tanks, dive this rebreather in the sea, full undergarments with no extra lead. So that means that this rebreather is pretty much the same as diving with a twin set for us. The weight of the rebreather itself, fully assembled, is less than the JJ because of the materials it's made from. So by not being an aluminium can, means that it's about 4 to 5 kilos lighter than a fully kitted JJ. Oh yeah, so you're right, Stuart. We do a long plate, which is so we'll grab one now. Rather than having a standard size back plate, which is what this one just happens to have on it, that's what we had lying around. So this has got a standard steel plate on it that stops here, and you can see the wing comes out the bottom. You also get one of these, if you like. And so this is a Scuba Force long plate. So it's a steel back plate. It's longer in design, so that means that the back plate sits securely on the floor. With the back plate sitting securely on the floor, that means it's got even more functional stability forward and backwards. The back plate is designed so on the bottom you have some holes that you can clip accessories to, or you clip your stages to. It's also quite a nice design because it thins out. By thinning out means it sits in the small of your back and doesn't stick out to the side so much. I mean, you get your suit inflation and everything tucked nice and neatly in. So the long back plate is a good idea with the rebreather. What other questions have we got? The flight weight with no cylinders. Will, figure that out for me. So I don't know the full flight weight without cylinders on. I'll just talk a little bit to you now about the side mount version of the rebreather. So the side mount version of the rebreather is a little bit different. The side mount version of the rebreather comes with some extra parts. So when you order a back mount version, you can order a side mount conversion kit. If you order a side mount version, you can order a back mount conversion kit. So we've got the two. If you got the side mount kit, what you get in the kit is you get the base plate. You get some hoses that allow you to re-change the hose configuration. You get some a little handle that you put on the top of the head to allow you to connect it with your bungee, and you get a side mount loop. Okay, this is not the new side mount loop. This is an old side mount loop. In fact, I think this is the Gollum Gear version. But the side mount loop is designed so the rebreather is going to sit against your side here, placed into the mouth. The can, like we said before, is designed without the adapter on it, the 11-inch adapter for the back plate, and the hose configuration is designed to allow you to plug in off-board gases. Okay, because this, when you dive with the side mount version, you don't have the tanks on the side like you do on the back mount version. You'll put the tanks somewhere else. A little bit depending on your configuration. Some divers like to dive with an oxygen actually strapped to the side mount machine and fed directly, and then their diluent would be another tank maybe on the left or underneath. Some divers like to put a diluent and an oxygen on the left hand side, both side mounted in, one as a side mount and one as a stage, and they will then come over and be plugged both into the side mount rebreather. Some divers elect to dive a back mount machine with a side mount machine on the side, and they'll probably dive the side mount machine as their main machine, and if they need to bail out, they'll bail out on, well, they'll bail out to open circuit first, but then they'll bail out onto the back mount machine. Some divers will dive the back mount machine, go to open circuit, and then bail out onto the side mount machine, and they'll carry the stages probably both left. But it depends a little bit on how you want to do it. In terms of side mount rebreather, it's a new thing. There's not a lot of agencies running courses, so there's not a lot of information about the way to do it out there. If you are interested in more information, let me know, and we can do a little bit of a more one-on-one session rather than a group session about the side mount rebreather. But the side mount rebreather is an option. You can buy it as a conversion kit for the back mount, or you can buy it in side mount only. What's the weight, Will?
23.
Without cylinders, the machine weighs 23 kilos, was.
Obviously that will depend on what backplate.
Okay. Obviously your own backplate and wing will make a slight difference to that, but that's the machine alone. One of the things I'll say is cool about the SF in particular is it comes with a big padded flight case. So whereas most rebreathers come in a crate, a big crate with foldable lid, this comes in a padded soft bag. So a lot like the big Fourth Element or Santee or what they call North Face bags. Similar to that, Scuba Force branded, but with padded foam insert designed to fit the rebreather inside. It's really, really nice. You pop your cylinders off and you just pop it straight in the bag. I can actually get the rebreather, my fins, my suit, all in the one bag and get it under the 30 kilo allowance with my steel backplate and everything on. So quite a nice machine for travelling with. Super simple. Let's take a look. What's the runtime on the scrubber? So the scrubber is a 3-hour C certified scrubber, exactly the same as the JJ. It's a 3-hour minimum, 3-hour maximum. It's an axial scrubber, so that means that gas passes from the bottom to the top, exactly like the JJ. So you have to travel with the special cylinder brackets. So yes, you need to have an adapter to put these into here. What we're using is the bracket with these Jubilee bands on. We can make a bracket, got a bracket with a cam band on. That means you can just cam band them on, exactly like you do on the JJ. But it does mean you need to travel with both the female and the male side. But I have seen people use a cam band all the way around the machine and then attach to that small cam bands. So it is possible, but again, better to travel with them. They're not hard. Once the cylinders are off, they stick on the machine and you can just travel with it on the machine. Okay, so I think we've answered most of the questions today. Right, so when we take a look at the SF2, what are some of its unique features? Unique features are the materials it's made out of. Made out of really durable carbon fibre. It means it's super light and super durable. The other components are made out of solid Delrin. Every part is machined down. So we've got really high quality tolerances, we've got really high quality materials, and very, very, very strong and stable. With the design is unique in the rebreather market really for ECCRs, is that we've got this counter-lung, the bellows version here at the base of the rebreather, means that there's less time for the gas to contact the water, so it keeps the temperature up. It also means that the counter-lungs are really well protected. No matter what you do, you can swim into a really sharp wreck and it's got to get through the carbon fibre before it gets to the counter-lung, so it's not like having an exposed counter-lung bag on your shoulder. Single feed for the MAV, so then both MAVs go into a single point. We have, of course, the fact that our system is designed so that if we lose onboard gas, plugging in offboard gas will activate all of the systems that were in there. Okay, that is a little bit dependent on what goes wrong. If you have a hose explode, you no point putting gas back into the system because they just go out the hole in the exploded hose again. So then you need to isolate it and still plug in and still run manually. So there's a lot of options with this rebreather in terms of failure modes. Having the isolator for the solenoids right at the first stage is really, really nice. It means that if you turn the solenoid off, it stops immediately. No gas flow. You don't have to wait for the hose to empty, you don't have to wait for the gauge hose to empty. If you isolate the solenoid is completely isolated immediately, no gas flow. So that's quite nice. The other really kind of cool features about the machine are the fact that it's very, very free around your front. As you saw earlier, if I take the loop away, really I've just got a backplate harness and a wing. So it's exactly the same as diving my twin set. I just happen to have a loop that I use. And in the event that I want to bail out, I can get rid of that loop completely, or I can pull it down over my chest and put my regulator in, and it's really, really simple. Another nice feature is the OPV on the base. If everything was going really, really badly and I started to ascend, I can just continually ascend without venting gas from the rebreather, and the gas will vent from the base automatically as I ascend. This will affect your buoyancy slightly, it will affect your trim slightly, but again, not the end of the world. You get yourself up to a depth at which you feel a bit more comfortable, manageable, and then you can start to vent gas from the rebreather and become more comfortable. We have the ability to isolate the MAVs without unplugging them, so we can isolate the gas flow and we can isolate the flow back into the rebreather using our gas isolators here. Functionality wise, in terms of our electronics, we have one primary set of electronics and a completely redundant backup monitor that doesn't have a battery inside the loop at all. Okay, so that's really, really nice. It means it's completely off board and completely separate set of electronics. The gas injection on this rebreather compared to the JJ, the gas injection is on the exhale side where it passes through the scrubber, through the inhale side. Another nice point is that boss where our scrubber connects, it means that if it was to get scratched or damaged, it's very easy and a cheap part to replace. The SF2 is really, really cool rebreather. I really recommend it for most diving. You know, it's happy in a cave, in a wreck, doing open water diving, shallow stuff, 35, 40 meter diving, 70, 80, 90, 100 meter diving as well. So it's very, very capable. It's very, very robust. We've been diving with our ones now for quite a while, and as you know, we tend to destroy something if it's capable of being destroyed. These have held up really, really well. We're a service centre for them as well. If you need service, we can manage that. We've got parts in stock. We've got instructors here ready to teach, so it's a really good proposition. Price wise, obviously it's available as a fully stripped rebreather, so I'll bring up the current pricing so you guys can see. We can buy it stripped, which means that the machine has got no cylinders, it's got no first stages, it's got no backplate, harness and wing. Okay, the fully stripped version of the machine is currently so the strip machine is 6,346, so 6,346, that's including VAT, ready to go. The full ready to dive machine, so with cylinders, with valves, with first stages, with a wing plate, harness, everything, just lime and gas, that's 7,825, including the VAT. We also do a stripped plus, which is the one that we think most people buy, which is a stripped machine, but we add the offboard connect, so the quick connectors, they're an optional extra, and we add all of the shut-offs to make sure that it works how we've shown you today, plus cylinders. So that's kind of version that you want to buy if you're going to use your twin set stuff, and that's 7,141. The side mount version, if you're interested, the side mount machine ready to go is 6,086 quid, and that again is fully set up with the loop and everything ready to go, but you're going to need to find a way of how you're going to configure that machine. The two conversion kits are about 2,500 quid each, depending if you want to convert from back mount to side mount or side mount to back mount. One way is slightly cheaper than the other. Scuba Force still manufacturing. They also manufacture a whole bunch of other products: dry suits, regulators, wings, plates, harnesses, accessories, spools, lights, all that kind of stuff. So you'll see Scuba Force becoming quite a bigger name in the UK over the next year or so. As we start to bring more parts and more stuff into the UK. We've got a few dealers around the UK now, so you'll see the benefit of it, of that base of dealers when you buy a rebreather, meaning that the accessibility of parts and stuff is going to be much more easier. More instructors coming on board as well. So that today was a rundown of the Scuba Force SF2. If you guys have got any questions, please feel free to stick those in the comments. If we can't answer them now, we'll answer them a little bit later on. The video stay up so you can share it with your friends. Our next one will be on Wednesday of next week. Wednesday of next week we're going to run through the AP Inspiration Evo. So we'll run through the AP next week and we'll show you a build up, strip down. Same thing, we'll compare and contrast the JJ now with the SF2 and with the Inspiration, so you get a kind of an idea about them all. If you guys are interested in rebreathers at all, please give us a shout, send us a message. When this lockdown's over, feel free to come into the shop. We have all the rebreathers here. We have multiple JJs, multiple SF2s, multiple Inspirations, multiple Poseidons, so you can come and see them, feel them, touch them, take them apart, and get really close and up ready with them. We offer training with your own rebreather. We also offer training with a rental rebreather, so you can borrow a rebreather from us and do your course with it. All in all, they're between the JJ and the SF2. Love both rebreathers, do equally diving on both. It's just a case of one has one skill set which is slightly different to the other, and depending on your thinking, one might be more suitable for your type of diving. We've got a question. Let's have a look at the question. What type of diving would I not recommend it for? So yeah, actually rebreather diving I wouldn't recommend doing in choppy sea in very shallow water. I made the mistake once of taking my JJ to dive in the Farne Islands, about 1.5 to 2 meters deep with about 3 meters swell. And it was awful. So you're constantly getting pushed up and down with the water, and the Catalan's constantly adding and contracting. The machine's trying to add oxygen to keep the PO2 stable at the depth. The depth is constantly changing, and that means you've got to keep venting and adding gas, and it just gets a little bit uncontrolled. It's not impossible to do, but it's much harder, and honestly, on open circuit, I would have felt better just for that really, really shallow diving. But that said, I've done some really fantastic dives at 8 or 9 meters on a rebreather in nice calm water. So for instance, in Egypt, if you go 10, 12 meters, you can stay there for 3.5 hours very, very easily and swim around and see a hell of a lot of reef. So not the depth that was a problem, it's the fact of that kind of choppy water. Okay, so yeah, how do I dual flush the rebreather? So there's no dump to pull. So when I add diluent, there's no dump to pull. Going to go a little bit into the skill set. I don't want to go too much into the skill set because it's kind of out of the scope of what we're doing. But with this rebreather, I can do a hands-free diluent flush if I like. Because the bellows is in the base, in the counterline, it's constantly being pushed up, even if I'm in trim. So what that means is, if I get to a position where I lift my chin and make the mouthpiece the lowest point, and I start to release gas from the side of my mouth, gas will come out from the rebreather. As gas comes out, the other gas is going to come up through the rebreather, and that's going to pull that bellows up. So as I'm releasing gas, the bellows is going to come up and hit the ADV. The ADV is going to fire gas up through the scrubber at a rate and push that gas out my mouth. So even if I'm holding my camera, I've got both hands busy, all I have to do, just make my mouth the highest point, release gas, gas will come out, and as the ADV fires, it's going to push all of the gas that's in the rebreather up and out through the mouthpiece, replacing it with fresh gas. So that's how I can do a diluent flush hands-free. I can also do it using the MAV in a very similar way, but a little bit more, I'd say, more for the training side rather than this video. Is there a shorter can? No. Well, there is a shorter can, but I'm not sure that. That you want to use it because it's not CE rated, so it's a shorter can. It means that the Catalan won't move up and down as much, and the only reason you won't want it is so that you can kind of sit down a little bit easier. We spend most of our dives diving rather than sitting down, so I wouldn't bother to change for the shorter can, but it is available. Not a problem at all. What the obvious mistakes people make with the SF2 during setup and diving? Very similar to all rebreathers actually. The biggest mistakes people make when setting up a rebreather is not following their checklist, skipping parts of their checklist, or assuming they know something. Following the checklist, it's really difficult to go wrong, but you need to be trained. Just the checklist alone isn't enough. You need to know what the checklist means and why every single item is on it. So the training together with a checklist during the build-up process could be quite nice. People tend to get interrupted during the checklist and wander off. They come back and they miss a step, stuff like that. Those are mistakes. Mistakes during diving. People make mistakes pushing their scrubber absorbent too long, not leaving adequate conservatism in their decompression schedule, leaving adequate conservatism in the amount of gas that they've got remaining, carrying enough bailout. Those are standard things, but that's all diving. The other thing people do is some people don't monitor their system well. If you're not monitoring your machine, obviously it's your life support piece of equipment, just like monitoring your SPG, you need to monitor the machine. And if it's not working, you need to know how to deal with that. The biggest mistake in my personal mind for all rebreather divers is that they believe they're more clever than the machine. If the machine goes wrong, they think, oh, I can fix this, I'll go for a whole bunch of skills to try and get myself to the surface safely, when the easiest and simplest option is just to bail out to open circuit and go up. So, in my mind, I think the biggest mistake people can make is by not following their training, which is mistake on the rebreather. You're not sure, just bail out to open circuit and go home safe. Fix your machine later. It's nice to have a skill set to be able to manually maintain it. If you're in an overhead environment a long way from home, you might want to maintain your rebreather a little bit longer just to shorten your decompression penalty, but you should still have adequate bailout. Adequate bailout, that's kind of the biggest killer for people not having enough bailout. And there's some few stories recently about some guy who died in a cave or a mine in the UK. I can't remember exactly what it was. Didn't have anywhere near enough bailout for the dive, and you know that's a stupid reason to die. Any other questions? Is there a radial scrubber available for the SF2? And the answer is no. There's no radial scrubber available for it. Just the standard axial, and there isn't a bigger scrubber as far as I'm aware either. So just the standard scrubber. Any other questions? No. I think that's it. So thank you very much for your time, guys. Of course, we'll still be monitoring the comments for the rest of the day. Please feel free to comment, send us private messages. Both me and Will can answer these questions for you. It's nice to see the guys from Scuba Force, Stuart and Tom online as well, kind of checking in, see what we're doing. If you want more info, let us know. Big announcement coming out tomorrow. I'll let you guys into a secret because you're with us. The JJ and the SF2 courses are now available for SSI. So from the 1st of May, keep a lookout for the post, but keep it to yourselves. And yeah, if you need to know anything more, please give us a shout, let us know, and we'll answer your questions. Cheers guys, have a really nice day, and we'll see you for the next one.